We're going to talk about the determinant of a matrix. The determinant of a matrix is a special number that can be calculated from the matrix. It tells us things about the matrix that are useful in systems of linear equations, in calculus, and more. One of the ways we can do a determinant is through our second order determinants, meaning it's just a 2 by 2. So we have our 2 by 2 matrix. All we're going to do is we're going to take these two numbers and multiply it. So we have A times D minus our B times C. And then we'll just give us our number. So for our first example, we're going to take negative 2 times 8, which gives us negative 16, minus 6 times 5 gives us a 30. So negative 16 minus 30 gives us a negative 46. So negative 46 is our determinant for this matrix. Now for our third order determinant, meaning we have a 3 by 3, it's a little bit different here. What we need to do is we take this first two columns and we throw them out on the side here. So we're going to take our A, D, and G. Then we're going to take B, E, and H. The reason we do this is because we're going to actually create these diagonals. So first and foremost, we're going to take our first diagonal this way here, then our next one, and then our third one. What we're going to do with the products of these is we're going to add them. So we're going to add the bottom products. Then we're going to create these other diagonals. So we have these three diagonals over here. Once we find the product, we're going to subtract those numbers here. So for our first example, we have our 3 by 3 matrix. So I'm going to take my first two columns and throw them out here. So I have 2, negative 1, 6, 7, 5, and 9. So I'm going to create my first diagonal. So I got 2, 5, and 0, 7, negative 4, and 6, negative 3, negative 1, and 9. So 2, 5, and 0, when I multiply them, gives me 0. 7, negative 4, and 6 will give me a negative 168. Negative 3, negative 1, and 9 gives me a positive 27. Now we're going to create our other diagonals. So we have 6, 5, and negative 3, 9, negative 4, and 2, and 7, 1, negative 1, and 0. So when we times 6, 5, and negative 3, we should get a negative 90. Negative 4, 9, and 2 should give me a negative 72. And then 0, negative 1, and 7 will give me 0. So what we're going to take is we're going to add the bottom products. So we're going to say, well, 0 plus a negative 168 plus 27. Then we're going to subtract the products from the top. So minus a negative 90 minus a negative 72 minus 0. And when you add and subtract all these, your answer should be 21. Now for area of a triangle, we use the determinant formula to find the area of a triangle. So the formula for this is area equals 1/2 of the absolute value of the determinant. The reason it's absolute value is because area can only be measured in a positive number, so whatever your determinant is, just make sure it's positive. So here we're given 3 points, which are the vertices of the triangle, and we need to put it into a matrix. Well, we have our point 1, point 2, and point 3. The last column is going to represent just ones. That way we can go ahead and do the determinant on this 3 by 3 matrix. So given our next example, we have an area of a triangle we want to find with the vertices of these 3 points. So I'm just going to create a matrix. So I got negative 3, 2, 1, 5, 4, 1, 3, negative 4, and 1. Now since we have a 3 by 3, we're going to take this first two columns and put them on the outside of here. So we got negative 3, 5, and 3, 2, 4, and negative 4. So we're going to go ahead and solve this by diagonal. So we got negative 3, 4, and 1, 2, 1, 3, 1, 5, and negative 4. So negative 3, 4, and 1 gives us a negative 12. 2, 1, and 3 gives us a 6. Positive 1, 5, and negative 4 gives us a negative 20. Then we're going to take our other diagonals. So 3, 4, and 1, negative 4, 1, and negative 3, and then 2, 5, and 1. So 3, 4, and 1 gives us 12. Negative 4, 1, and negative 3 gives us a positive 12. And then we have 1, 5, and 2 gives us a positive 10. So first and foremost, we have to find our determinant for this one. Remember, you have to add the bottom and subtract the top. So we're going to say, well, negative 12 plus 6 plus a negative 20 minus 12 minus 12 minus 10. So our determinant is going to equal negative 60. Now remember, it's half of this of the absolute value. So 1/2 of the absolute value of negative 60 is going to equal 30 units squared. Now our identity matrix. With identity matrix, they're only the square ones, so 2 by 2s, 3 by 3s, 4 by 4s, and so forth. What happens is it has the same number of rows and columns, where the main diagonal, which is from your upper left to bottom right, is full of ones, where the rest is zeros. So you have your main diagonal here, and your main diagonal on your 3 by 3 over here. Now, when you get a question saying, are these two matrices inverses of each other? What that means is if these two are inverses of each other, which we're going to get to in just a minute, we want to figure out what are they equal to. So you have to multiply your matrix A times matrix B. If that gives you one of these identities, then they are inverses. If it doesn't give you this array of numbers, then they're not inverses of each other. So now I was talking about inverses. Now, with an inverse, we have to understand what the determinant is again. So we're just going to be doing inverse matrices on 2 by 2s. Now, if the determinant is equal to 0, an inverse does not exist, because if you look at the formula here, 1 over 0 is undefined. So we have our matrix A of our A, B, C, D. The inverse of matrix A, you're going to do 1 over your determinant. Then if you look at this matrix over here, your A and D are flipped, and you change the signs on B and C. So for our last example, the first thing we have to do is we have to find our determinant. So we're going to say, well, 2 times 1 is 2, minus 6 times negative 5, which is a negative 30. So this is going to equal 32. So what we need to do is to find the inverse. We're going to say, well, 1 over 32, because it's 1 over our determinant, times this by our matrix. Now, we have to flip our D and A. So when 2 and 1, it's going to be 1 and 2. Now on the 6 and negative 5, all we have to do is change the sign. So since it's negative 5, it's now positive 5, and now it's a negative 6. Now, 2 ways you can leave your answer. You can leave it this way, or you can have it distributed into your matrix. So you're going to say 1 over 32 times 1 is 1 over 32. Then you have 5 over 32. Then you're going to have a negative 3 over 16, which is reduced. And then your 1 over 16. So you can see the inverse sort of written in 2 different ways.